Hello, this is Gregory Maxwell, and today's lesson is about lines and linear functions. And I am giving credit here to Professor Shauna Hayter of Salt Lake Community College, who's has created PowerPoints that cover this concept, and I am using some of her slides as part of this lesson. This lesson will go in phases. We're going to first talk about slopes and how to determine slopes from a graph and from 2 points, as well as how to graph to determine the slope from the equation. And then we'll talk about getting the equation of a line given 2 points or given a slope and the slope and a point on the line, and also from the graph. So let's get started. Now, to begin, all of this is to help us to find a way to describe a line algebraically. In other words, the equation of a line. This concept is based on what we call the unique line postulate, which says if we have 2 points in space, there is exactly one line that will pass through those 2 points. It's a unique line. There's always a line that goes through 2 points, and that will be the only line that will go through the 2 points. Now, in order to find the equation of a line, we need to know both of the following bits of information. We need to know the slope of the line, which tells us what direction the line is going and how fast it is doing so. In other words, the rate of change of the line. And we also need to know a point on the line. And what the point does is tell us the location of the line in the plane, in the coordinate plane. Now, in this lesson, we're going to focus on the two-dimensional coordinate system. That means the XY plane. But of course, this can be generalized to a three-dimensional system, which is the XY and Z plane. But for this lesson, we will be focusing only on two-dimensional coordinate system. Now let's talk about the slope. The slope of a line is a number that tells us how steep the line is and in which direction it's going. In other words, how fast does the y value change compared to the x coordinate. The bigger the slope, in terms of the size, is the steeper the line. And the smaller the slope in terms of the size is the less steep the line is. So for example, this line here is the steepest line, so it will have the largest slope. And since the line is increasing, we will give it a positive, because generally speaking, when something is going upward or increasing in mathematics, it usually gets the positive designation. And when it's going downward or decreasing, that will be a negative designation. So this line is the one that is increasing the fastest, so its slope will be the biggest positive. In other words, the greatest slope. And then that line there will be the one with the smallest positive slope. It will be rising the least. So that then will indicate that the slope is the smallest number. On the other hand, if the line is decreasing, the slope would be negative. And the steepest line will still have the largest in terms of size slope. That's not the same as greatest. Largest means biggest in size. So this line here has the largest slope. Its absolute value is the biggest number of all of these. And this line will have the smallest in terms of size. Its absolute value will be the least. But both slopes will be negative because both lines are decreasing. Now, how do we determine the slope of a line? The slope of a line is the rate of change of the y value with respect to x. In order to do that, we have to find out how much the y value changes versus how much the x value changes. The change in y value is called the rise, which is y2 minus y1, the second y value minus the first y value, over the change in x value, which is called the run, which is the change x2 minus x1. So we have 2 points, x1, y1, and x2, y2. In this case, this illustration, we're going to use x1, y1 as a point to the left and x2, y2 as a point to the right. And we're going to look at how much the line, the slope, how fast the line is changing position. In other words, the rate of change of the line, the slope of the line. We look at the change in y, which is y2 minus y1, and the change in x, which is x2 minus x1. The change in y is simply how much do I go from the first y value to the next, and the change in x is how much do I go from the first x value to the next. x2 minus x1, y2 minus y1. The slope is how fast the y value changes with respect to the x value. In other words, rise over run. The change in y over the change in x. So the slope, which is represented by the symbol m, lowercase m, is change in y over change in x, rise over run, y2 minus y1 over x2 minus x1. Please note in this formula that this is the slope formula, that if you put whatever is the y2, if that's first, then the x2 must be first below. The change in y is above in the numerator, and the change in x is below in the denominator. This is the slope formula which you will need to memorize. This is the formula that is very important in mathematics at basically all levels. It comes up everywhere. So you need to make sure you know how to do this. So let's see an example here. Let's figure out the slope of this line from this graph. To find the slope of the line, what you do is you choose 2 points on the graph that are clearly identified. So you want the line passing through 2 points that are corners of the squares, so you can tell specifically what particular coordinates those are. For example, I could choose this point here, which is 0, 0 for x and y, and this point, which is 1, 2, 1 for the x, 2 for the y. Or I could choose another 2 points, it doesn't matter. I could choose instead these points up here, or I could choose these points down here. Either way, it will give me the same slope. So I go up 2 units to go from this point to this point. I go up 2 units and over to the right 1 unit. So the slope is 2 over 1, rise over run. Or I could use the slope formula, change in y divided by change in x. 2 minus 0 over 1 minus 0. Either way, the slope is 2. If I choose 2 different points, say this point here that's going through the corner, that coordinates are -2, -4, and this point is going through another corner, 2, 4, I will get the same result. This rise will be 1, 2, 3, 4, 5, 6, 7, 8 units up, and to the right, 1, 2, 3, 4 units. So it will be up 8 over to the right 4. 8 divided by 4 will give me 2. Or I could use the slope formula, y2 minus y1, 4 minus -4, which is 4 plus 4, which is 8, and x2 minus x1, 2 minus -2, which is 2 plus 2, which is 4. It gives me the same result. It doesn't matter which 2 points I choose on the line. For the same line, the slope will be the same result. All right, here's another example. This line is a horizontal line, which means the y value does not change. That means there is zero change in rise even as we go along the x-axis. That means the slope will be 0 over a number. Let's say I choose this point, -4, 3, and this point, 2, 3. The change in y would be 3 minus 3, which is 0, and the change in x would be 2 minus -4, which is 6. It's 0 over 6 because as long as the y value does not change, the change in y is 0, and the x could be changing all at once. The top will be 0, and the bottom is some other number. 0 divided by another number is 0. So we see here that for a horizontal line, the slope is 0 because this line is neither rising nor falling, it is staying constant. And the reason it is staying constant is that the y-coordinate does not change. The y-coordinate is always the same number, it is a constant. In this case, the y-coordinate is 3. So this equation, this line could be represented by the equation y equals to 3. In other words, it's saying y is always 3, regardless of what the x-coordinate is. Generally speaking, if the line is a horizontal line, all we have to do is determine the y-coordinate, and then we're saying the y value is always equal to that coordinate. So y is always equal to b. And so the equation of a horizontal line is y equals to b, where b is the y-coordinate of any point on the line because the y-coordinates do not change. Here's another one. This, of course, is a vertical line, which means the x-coordinates do not change. X equal to -2 in this point, -2 in this point, -2 in this point. The slope then will be rise over run. The problem here is even though we're rising, we're not changing x values. There's 0 run. So we have a change in y over 0. Well, we cannot divide by 0 because dividing by 0 is undefined. That means there's literally no number that results. And so the slope of a line that is vertical does not exist. There is literally no number that will work. We say that the slope is undefined. And so when a line is vertical, it has no slope. The slope is undefined. So it's a vertical line has no slope, which is different from zero slope. Zero slope is a horizontal line. A vertical line has no number that corresponds to the slope. Since it's a vertical line has no number that corresponds to the slope. It's because the x value does not change. So the equation of a vertical line would be x is always the same number. In this case, x is always -2. So we're saying x is equal to -2 regardless of whatever the y value is. So generally speaking, when we have a vertical line, the equation is x equal to a, where a is the x coordinate of any point on that line. X is equal to the x coordinate. So generally speaking now, we can then say, and I forgot to correct this here. Let me just make that quick correction right here. Um, there we go. So when we have a line with that is increasing, the slope is positive. When the line is decreasing, the slope is negative. When the line is horizontal, the slope is 0. All right. When the line is vertical, there is no slope. The slope is undefined. Undefined. There is no number that corresponds to the slope. So let me just draw a little graphic here just to help us to recognize what these lines look like. An increasing line is a line that goes upward as we look from left to right. A decreasing line is a line that goes downward as we go from left to right. A horizontal line does not go upward or downward. It's like level, parallel to the x-axis. The x-axis is a reference horizontal line. And so a line that is horizontal is parallel to the x-axis. It just goes straight across from left to right. It neither increases nor decreases. And a vertical line is a line that goes straight up and down. It has no number that gives you a slope. The slope does not exist. Please note, do not make the error of confusing slope with zero slope with no slope. No slope means there is no such number. Zero slope means it's a horizontal line. There is no increase in y, no change in y. So here's a quick little summary sheet again. When you're calculating the slope, you just do rise over run, or the change in y over change in x, or y2 minus y1 over x2 minus x1. You can use the graph, or you can use the equation. If you're using the graph, choose 2 points that can be clearly identified, and then do the change in y upward over the change in x, rise over run, or you just choose the coordinates of the point and plug them into the slope formula, and then work out the equation, simplify. When you're doing these, I strongly recommend that you use you do it by hand. In other words, you need to practice working with fractions, simplifying, and so on. Another part of the summary here, just to remember that when a line is increasing, its slope is positive. When it's decreasing, the slope is negative. And we talk about increasing and decreasing going from left to right. And horizontal lines have a slope of 0, and vertical lines do not have a slope. The slope is undefined. If the steeper the line gets, the bigger the slope, positive or negative, and the less steep the line is, the more leveled off it is, so to speak. The smaller the slope, positive or negative. So remember now, smaller does not always mean positive. Does not always mean less. Smaller just means size. Less means to the left or below. Greater means to the above or to the right. Now let's do a quick example here of calculating slope. So determine the slope of the line containing the 2 points and indicate whether the line is increasing, decreasing, horizontal, or vertical. Since we have 2 points here, we simply use the slope formula. I typically write the formula m equals to y2 minus y1 over x2 minus x1. And for at least initially, I would recommend that you label your points. You can call either point x1, y1. Just keep the x1s and the y1s together and the x2s and the y2s together. Doesn't matter which one you choose, which point you choose as x1, y1, and x2, y2. Just make sure you're choosing the points together, the x2 and the y2 together. In this case, y2 is -3 minus y1, which is 0. And x2 is 0 minus x1, which is 6. So it's -3 minus 0 over 0 minus 6, which is -3 divided by -6. And we simplify that, divide top and bottom by -3, we get +1 over 2. So the slope is half. Since this slope is positive, then this line is increasing because the slope is a positive number. Slope is a number that's greater than 0. A positive slope means an increasing line. There you have it. It is that easy. Let's take a look at this other example now. And I would recommend that you try these questions ahead of time and then come back and check your answers compared with my answers. So again, write the formula m equals to y2 minus y1 over x2 minus x1. Identify your points, x1, y1, x2, y2. Insert your points into the formula. 1 minus 5 y2 minus y1 over -7 minus -2. And in this case, 1 minus 5 is -4. -7 minus -2 is -7 plus 2, which is -5. We get -4 over -5, which is a negative divided by a negative, which gives you a positive 4/5. And again, since the slope is positive, this line is an increasing line. And there you have that. Let's try this with decimals. Same deal. Write our formula. M is equal to y2 minus y1 over x2 minus x1. And I'll label my points again, x1, y1, and x2, y2. And so I do -0.1 minus negative 0.2, and that's divided by 0.3 minus 0.4. Now, -0.1 minus 0.2 will give me -0.1, -0.1 plus 0.2, which is +0.1. And then this is over -0.1. So a positive divided by the corresponding negative is just a negative, and the slope is -1. The slope is negative, so this line is decreasing because the slope is a number that is less than 0. The slope is less than 0. Now let's try this one, number 4. In this case, again, we do m is equal to y2 minus y1 over x2 minus x1. When I do that, I get 7 minus 3 y2 minus y1 over 2 minus 2. 2 minus 2. That gives me m is equal to, say, 4 over 0. This is undefined because we cannot divide by 0. Since the slope is undefined, we then realize that this line is a vertical line. Vertical line, which means the equation of the line is x is equal to 2. In other words, the x coordinate is always the same. Take a look at that. The x coordinate here is 2. The x coordinate here is 2. That's a vertical line, so the slope is undefined. And as I said, the equation is x equal to 2. X doesn't change. As you can see here, if you look at these 2 points now, the y coordinate is the same, -1 and -1, which tells us what? It tells us that the line is a horizontal line since the slope doesn't, the y coordinate doesn't change, which means we should anticipate that the slope is 0. So let's do that. y2 minus y1 over x2 minus x1. y1 is -1, y2 is -1, and x2 is -3, and x1 is 5. When we do that, we get m is equal to a number minus itself is 0, and -3 minus 5 is -8. 0 divided by any other number is 0. So since the slope is 0, we have a horizontal line as we expected. Horizontal line. And since it's a horizontal line, that means the y value doesn't change. And in this case, the y value is always -2. So that's the equation of this line. Once we have a horizontal line, the y-coordinate will always be the same number. And all you have to do is just take whatever the y-coordinate is from any of the points, since they're the same y-coordinate, and y equal to that number is the equation of the line. Now, this one looks a little challenging. It's just a couple of fractions. It's not a problem. It just looks difficult. We'll follow the same procedure. Y equals to, oh, sorry, excuse me, m equals to y2 minus y1 over x2 minus x1. And then that is 1 minus 4/3 over, and this is 7 over 1, which is just 7 minus 3/2. And then what we're going to do here, is, oh, I see where I made it. This was originally supposed to be 7 over 2. So let me just make a quick adjustment to that here, because I want to use this as an illustration. All right, so we're back to the example here. And there we have it. So we have 7 over 2 minus 3 over 2. Now, we can simplify the denominator and simplify the numerator, or we can find the common denominator, the least common multiple of the denominators. The denominator here is 3, the denominator here is 2, so we're going to multiply those two numbers and we get 6. So the common denominator is 6. And then what I will do is multiply all the fractions in the numerator by 6 and the denominator by 6, distributing that 6 to each fraction. And what will happen is the following. We will end up with m is equal to 6 times 1 minus 6 times 4 over 3 divided by 6 times 7 over 2 minus 6 times 3 over 2. That gives me 6 minus 24 over 3, which is 8. And 6 times 7 is 42 over 2 is 21. And 6 times 3 is 18 over 2 is 9. And now all the fractions have been canceled. And now it's just a simplified negative 2 over 21 minus 9, which is 12, sorry. 21 minus 9, which is 12. Now, 2 over 12 is just 1/6. So this is negative 1/6. So what we have here is a decreasing line, because again, the slope is negative. And there we have it. So when you have fractions, just multiply numerator and denominator by the common denominator, and then you can just simplify your fraction. Work with the whole numbers and simplify the results afterwards. All right, let's see if we can fit this other one in the space here. Similar situation here. And now the slope is m is equal to y2 minus y1 over x2 minus x1. And y2 is negative 3 over 2 minus negative half. And then y1 is negative 1/6 minus 2/3. Again, the common denominator is 6 because all 6 is a multiple of all of these denominators. So I'm going to multiply numerator and denominator by 6. When I multiply by 6 and I distribute the 6 to each fraction, what will happen is, I'm not going to show that part here just because of the space. 6 times negative 3 halves, it's negative 3 times 6, which is negative 18, divided by 2 is negative 9. And negative times negative is positive. So we're going to get a positive here, and half times 6 is going to be 3. 6 over 2 is 3. And then the denominator, 6 times negative 1, 6 is negative 1. And 6 times 2/3, 2 times 6 is 12, divided by 3 is 4, so it's negative 4. Negative 9 minus 6, negative 9 plus 3 is negative 6. And negative 1 minus 4 is negative 5. So once we complete that, we see negative divided by negative is positive. So my slope is 6 over 5, which means this line is increasing. And there we have it. And of course, most of these questions are done very similarly. Let's move on to just a few more examples here before we go on to the next concept. Determine the slope of each line. Now, this line is clearly a horizontal line. Since this line is horizontal, then what is the slope? Since the y value doesn't change, there's 0 change in y, so the slope is 0. This line here, what we do is we choose two corners. They can be right next to each other, or they could be just distance apart. And we see that the slope here is rise over run. And let's see, we go up 2 units and over to the right 2 units to go from one point to the other. So rise over run is 2 over 2, which is 1. And so the slope is 1. Then in this case, the first corner here is, and we see the line is increasing, so we should get a positive slope. The corner square is here, the next corner square is all the way here. So again, the slope is rise over run, which in this case we go up 1 unit, and then we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going over to the right 10 units. So the slope here is 1 over 10. And there you have it. M is equal to 1 over 10. Let's continue with this one. This is clearly a vertical line. So the slope of this line is undefined. M is undefined. No slope. No slope. This line is decreasing, so the slope should be a negative. So we're doing M is equal to rise over run. We choose some corner squares. We can go from this corner to, say, this corner here. And as you can see, we go downward 3 and to the right 3. So downward it's negative 3 and to the right it's positive 3. Negative 3 over 3, which is equal to negative 1. Or you could say we go to the left 3 and up 3, which would be now 3 over negative 3, still negative 1. So the slope is negative 1. Let's say we're going from, for this one, there's a corner point right there and a corner point right, say, here. Well, let's change it to, say, here. That means we go down 2 units and then to the right 4 units. So the slope, which is rise over run, is equal to negative 2 over 4, which will give me negative 1/2, which we expect a negative because the slope is a negative number. So let's move on to the next concept here. When you're trying to find the equation, when you're finding the equation of a line, please remember what we said. You need to know the slope and a point on the line. Now, if you have 2 points now, since we've just learned how to find the slope, that's fine. Once you have 2 points on the line, all you have to do is calculate the slope by using the slope formula, or if the points are plotted on a graph, using rise over run. Once you know the slope from those 2 points, just choose any of the points, and you can use that point to find the equation of the line. We're going to see how we do that in a minute. Just remember that the slope of the line tells how slanted the line is relative to the x-axis. We're going from left to right. This indicates how fast the line is increasing or decreasing. So it's called the rate of change of y with respect to x. And the point just tells us where the line is resting in the xy coordinate plane. So let's take a quick look at this example here. I have 2 points, -2, 4, and 2, -4. Let's plot them. So that's the line there, -2, 4, and 2, -2. We know that the slope then is, we know that the slope is a negative number. What is the equation of the line? So we just find the slope first. We do y2 minus y1 over x2 minus x1. The slope works out to be -3 over 2, a negative as we expect. So let's say we just choose an arbitrary point on the line, xy. We don't know the coordinates xy. In fact, xy could be anything on the line. So xy are called variables. The values of x and y change as you go along the point. It varies along the point. Now, let's say I choose one of the 2 points, namely 2, -2. What would be the slope of the line from xy to 2, -2? That slope is -3/2, because the slope on the line is always the same regardless of which 2 points we choose. Using the slope formula then, m, which is -3 over 2, is equal to y2 minus y1 over x2 minus x1. I just choose y2, x2 and y2 as the arbitrary point, xy. So y2 is y, and x2 is x. And y1 is the y coordinate of the point that I know, and x1 is the x coordinate of the point that I know. So the slope formula becomes m equal to y2 minus y1 over x2 minus x1. M is -3/2 equal to y minus -2 over x minus 2. Simplifying, I get this little simple guy here. If I multiply both sides by the denominator, I get -3 over 2 times x minus 2 is equal to y minus -2. This is called point-slope form of the equation of the line. Any x and y coordinate I choose on the point on the line will satisfy this equation. And now if I solve this equation in such a way that I get the x and the y together and there are no fractions, all I will have to do is distribute the parentheses. So I'll distribute the -3/2 by x, and the -3/2 times -2 will be +3. Then y minus -2 is y plus 2. And if I multiply both sides by the common denominator, which is 2, I would get, or in this case -2, I would get 3x minus 6, because -2 times 3 is -6, equal to -2y minus 4. And then I can move the -2y together with the 3x. So I get 3x plus 2y, and then I add the 6 to both sides. And this is called standard form of the equation of a line. If we put all the numbers and variables together on one side and equal it to 0, that's general form. Sometimes the two forms are used interchangeably. So what we have here is this standard or general form of the equation of a line, which says any two x and y coordinates that satisfies this equation represents a point on the line. So if x is 0 and y is 1, then the point on the line would work. So that's a point on the line, 0, 1. All right. So this is one form of the equation of a line called standard form. And we can then, I mentioned something about point slope form. If I get to start out with the slope formula, let me back up here a bit. If I start out with the slope formula, m equal to y minus y1 over x minus x1, where x and y are just some arbitrary point on the graph, and x1 and y1 are just coordinates of a known point on the graph. I can rearrange this equation by multiplying both sides by the denominator of the fraction. This is x minus x1. And then my equation becomes y minus y1 is equal to m times x minus x1. This form of the equation of a line is called point slope form. Point slope form. And it's called point slope form because it tells us a point on the line and the slope of the line. Slope is m and the point of the line is x1, y1. That helps a lot to know x1, y1. That helps a lot to know what we're working with. So once I know a point and the slope, I just put it in the equation in point slope form. This is a functional form. It's not our favorite form, but it's a very useful form because we can get to other forms of the equation of a line relatively easily from this. Now, let's say we have a point and that's on the line and the slope. Let's find two additional points on the line. What we do is plot the point, -1, -5. And then the slope tells me that the slope is 2, which is really 2 over 1, which means I will, from this point to get to another point, all I have to do is rise 2 and then run along 1. The change in y is 2 and the change in x is 1. So I go up 2 units and then go over to the right 1 unit. And that lands me at this point here, 0, -3. So 0, -3 is another point on the line. I do it again from 0, -3, up 2, and then over 1 unit at one more time, up 2 over 1. That lands me at this point here, which is as coordinates 1, -1. So that's another point on the graph. So right now we see then that the slope will allow me to get multiple points on the graph. And once I have multiple points on the graph, I can use those points, join those points, and that will give me, I'm not going to show the whole thing here, that will give me a line. On the next slide, we'll show the line more clearly. So the line looks like this. Now, how do I get the equation of the line? Simple. Put the line in slope-intercept, in point slope form. The point is x1, y1. So x1 is -1 and y1 is -5 and the m is 2. So I substitute y minus y1 equal to m times x minus x1. y1 is -5, m is 2, x1 is -1. Then I simply simplify. I can distribute the parentheses, put the x's and the y's together. So I'll move this y over to the left side, subtracting y from both sides and subtracting 2 from both sides. And this equation is now in standard form. If I plug in 0 for x, I get y equals to -3. So the y-intercept is 0, -3. If I plug in 0 for y, the x-coordinate is going to be 3/2. So the x-intercept is 3 over 2. Now, let's go on to another little thing here. The y-intercept is -3. So this tells us another nice little point, way of writing the equation. A way that tells us the slope and where the line crosses the y-axis, called the y-intercept. Those two things are very, very useful. In fact, this form of the equation of the line is extremely useful because when we want to write the line as a function, this is the format we write it in. It's called a linear function where the y represents the output of the function and the x is the input of the function. So we have this format called the slope-intercept form. It is the most useful and most preferred form of the equation of the line. Y equals to mx plus b, where m is the slope of the line and b is the y-intercept. Hence the term slope-intercept, because it tells us the slope of the line and the y-intercept. If you have an equation in general form or standard form, this is technically called general form because all the variables and numbers are on one side and 0 on the other side. All you have to do to get the slope and the y-intercept of the line is to solve for y. So we're going to get y by itself. I add 4 to both sides and I subtract 3x from both sides. Then I divide both sides by the coefficient of y. In this case is -4. Dividing both sides by -4 means I divide each term by -4. So -3x divided by -4 becomes +3/4 x. and 4 divided by -4 is -1. This tells me that the slope of this line is 3/4, and the y-intercept, where the line crosses the y-axis, is -1. That brings me to how I can sketch this graph. I know a point on the graph, namely -1, the y-intercept. So I'm going to plot that point first. I'm going to plot the y-intercept where the line crosses the y-axis, -1. Then the slope says to get another point, go up 3 units and over to the right 4 units. So I now use the change in y, up 3, and the change in x, over to the right 4, and now I have another point. And now that I have 2 points, I can just draw a straight line through the graph. And there I have my equation of a line. So let's do a quick example here. Determine the slope of the line and the y-intercept. Very simple. Try to get the y by itself. So all we're doing is solve for y. And slope-intercept form, if we get the equation in y equal mx plus b form, immediately we'll see the slope and the y-coordinate of the y-intercept. The x-coordinate of the y-intercept is 0 because on the y-axis, the x-coordinates are 0. So what I will do is I will simply subtract -3x from both sides, or actually add 3x to both sides, so that I can isolate the y. I cannot add the 3x to the 2, so I just write them next to each other. So the equation is y equal to 3x plus 2, and that means my slope is 3 and my y-intercept is 2. So slope is 3, or 3/1, and the y-intercept is the coordinates 0 for x and 2 for y. And there we have it. Piece of cake. Let's try this one here. Again, solving for y, we're going to add 7x to both sides. And then we have -y is equal to positive 7x minus 5. But then we have a -y, we want a positive y. So now we're going to divide both sides by -1. And dividing both sides by -1 means divide each term by -1. So now y is equal to -7x plus 5. So my slope for this line is -7. That means it's a decreasing line. And then my y-intercept has coordinates 0, 5. That's the crosses the y-axis at the point 0, 5. 5 on the y-axis. Now to get the slope of y-intercept here, I simply, again, subtract 17x from both sides. And that equation becomes y is equal to -17x. Now, where's the b? If there's no number there, you can recognize that that means we're adding 0. So even though we don't have an indicated y-intercept, an indicated constant, we can recognize that really there was a 0 there. So the y-intercept, the slope is -17, again a decreasing line, and the y-intercept in this case is 0, 0. It passes through the origin. In this case, this line has no x's in the equation, so we just simply solve for y. I'm going to divide both sides by 2. To get the y by itself, and I'm going to reverse it using the symmetric property of equals. I get y is equal to 9. And we should recognize this as a horizontal line. This is a horizontal line. And that means the slope is 0. And in fact, then, the equation could be thought of as y is equal to 0x plus 9. So then the slope is 0, and the y-intercept is 0, 9. In fact, every y-coordinate on this line is 9. In this case, we're going to multiply both sides by the reciprocal of half to get the y by itself. So I'm going to multiply by half. Half times -7 is -7/2. Again, we can see then that this can be written as y is equal to negative, is equal to 0x minus 7 over 2. And that means the slope is 0, making it a horizontal line. And the y-intercept is at the point 0, comma, negative 7 over 2. Now, if there's no y in the equation, then that means it's a vertical line, and you just solve for what? Solve for x. Don't have an example here, but you get the idea. And I may just add an example at the bottom here to illustrate. So for this equation, it looks a little bit more complicated, but it's the same process. We simply isolate the y systematically by getting rid of the weakest link by doing reverse PEMDAS. So I subtract 8x first, and I end up with 12y is equal to negative 8x plus 9. And then I will divide both sides by 12. I'm going to divide both sides by the coefficient of y. Dividing both sides by the coefficient of y, I get y is equal to negative 8 over 12, which simplifies to be negative, divide top and bottom by 4, 2/3. And then I put the x next to it. Not at the bottom, but next to it. And then 9 over 12 will divide top and bottom by 3. We get 3/4. So we have a decreasing line here whose slope is a negative number, negative 2/3. And the y-intercept has coordinates 0, 3/4. So crosses the y-axis above the x-axis. In this case, this equation is already in slope-intercept form, y equal to mx plus b. So the slope here is 0.625, which you could write that as 625 over 1,000. And if you simplify that, you will see that that works out basically to be 5 over 8. You can simply simplify by dividing the numerator and denominator by 125. Or if you have one of those fancy calculators, you just simplify that fraction on your calculator. I would recommend that you do that by hand and then get some practice with it. So the slope is 5/8 and the y-intercept is the point 0, 1.2, or 0, 12 over 10, or 6 over 5. This one is similar. Again, the slope is negative 2.5, which is negative 2.5, which is negative 5 over 2. It's a decreasing line. And the y-intercept has coordinates 0, 1.8, which you could write as 0, 9 over 5. I said I would do another example here, so let's quickly drop in another example right here. Let's see, we have a point, a line. Let's just write it in formally here. Number 9, 4x equal to 20. So we are trying to find the slope and y-intercept of this line. So what we would do is, since there's no y, solve for x. So no y, so solve for x. When we solve for x here, we'll end up with x is equal to 5. Since that's x equal to 5, we're talking about a vertical line. And if we have a vertical line, Unless it's the y-axis itself, there is no slope. That's even for the y-axis, but there is no y-intercept either. It does not touch the y-axis, and it has no slope. So a vertical line does not have a slope, and if it's not the y-axis, it doesn't touch it. And that's the example there. All right, let's now move on to the next concept. Okay, so just to remind us of what equations we just went through, we have a number of forms of the equation of a line. The favorite form is slope-intercept form. Whenever you have a linear function, the equation is in this form, except that instead of y, where they may use the name of the function f of x or g of x and so on. And then the slope here is m, and the y-intercept where the line crosses the y-axis is b. That's the best form of the equation of the line, the most useful. The other form is point slope form, which tells us a point on the line, and the slope. This form is extremely useful to find the equation in other forms, particularly slope-intercept form. And then this is the general form of the equation of a line. And the general form can also be compared with the standard form. And standard form is simply the general form with a constant on the other side of equal. So with standard form, and let me just type that up, standard form, I will show you what that looks like. That looks like ax plus by equals to a constant c. All right, so that is standard form. The only real difference between general form and standard form is whether the constant is on the right side or 0 is by itself. And sometimes they look exactly the same. So there's a very little difference between the two, and so you don't really have to worry about confusing the two. They're close enough that it's not a big issue. I'm going to make this a little bit bigger just so that we can see this a little better. It's not a problem here. All right, so there are two other forms of the equation of a line that we want to look at. Remember, we have the vertical and the horizontal line. The horizontal line, y equals to b. There's no x in the equation. The slope is 0, and there's no x-intercept unless the line is the x-axis itself. It's a horizontal line. A vertical line, x equal to k, where k is the x-coordinate of every point on the line. There's no y in the equation. The slope is undefined. That means there's no number for the slope. And there's no y-intercept unless the line itself is the y-axis. So let's move on here. By the way, a vertical line cannot be a function. We'll see that in the lessons on functions. So that's a quick point here about graphing a line. When you're graphing a linear equation, you need 2 points. Very simply, if you have an equation, you just determine 2 points by simply plugging in an x-coordinate and finding the corresponding y-coordinate. Like in this case here, when you plug in an x-coordinate to get like -1, you get a y-coordinate -1. You plug in 0, you get 2, and you plug in 1, you get 5. These are 3 points on the same straight line. Just plot any of these 2 points and draw a straight line through them. For more precision, you may plot all 3 points and then draw the line through all 3 to make sure the line is correctly calibrated. But all you need for the equation of a line to draw it is 2 points. If this equation is in slope-intercept form, the point is given. The easiest point is there, the y-intercept, 2. Start with the y-intercept, and then use the slope to get another point. And then you can use the slope to get a third point if you wish. But all you need are 2 points. Start with the y-intercept, then use the slope to get another point. And once you plot the 2 points, draw a straight line through them. If you're given the slope and a point, just as we said, plot the point and then use the slope to get another point by doing what the slope says, rise over run. If the rise is negative, then you go downward. If the rise is positive, you go upward. If the run is positive, you go to the right. If the run is negative, you go to the left. So let us take a quick look at a few examples here. So plot the graph these lines and then identify two other points. First point is 0, 0. That's the y-intercept. That's the origin. The slope is m equal to 2, which means it's 2 over 1, which means I go up 2 units and to the right 1 unit. Here's 1 point. So other points on this line would be 1, 2. In fact, I could also rewrite this as negative 2 over negative 1 because a negative divided by a negative is still a positive. So I could have gone down 2 over to the left 1, and I could have done it multiple times. So another point I could have written would have been negative 2, negative 4, or I could have done negative 1, negative 2. Now, I only need 2 points. I drew multiple points that were not absolutely necessary, but I did that to make sure that my line would be precise. So now I just join all those points together with a straight line going through all of them. And there we have our line with multiple points. And you can see the line went through that additional point, which is slightly off, but there we go. 2, 4 is another point. This line has an undefined slope. If the slope is undefined, then what type of line are we dealing with? A vertical line. If this line is a vertical line, then it goes straight up and down. I choose a point, the point 2, negative 3, 2, negative 3. And then I draw a vertical line that goes through that. And we see here that that means any point on that line where the x-coordinate is 2 works. So other points then would be basically any point where the x-coordinate is 2. So we are talking about 2, 0, talking about 2, negative 5, we're talking about 2, 4. So many different possibilities. In this case, this slope is 0, so we know that this is a horizontal line, which means the y-coordinates do not change. So I look for the point negative 2, 4, negative 2, 4, and then I draw a horizontal line through that point. And that means other points on the line are just points where the y-coordinate is the same, 4. So something 4. Something 4. They asked for only 1, but I'm putting 3. So I could have used 0, 4. I could have used 3, 4. And I could have used negative 5, 4. That's a horizontal line. If you notice, y doesn't change, so the equation is y equal to 4. And in this equation, x is equal to 2 all the time. Let's move on down here to this example. M is equal to negative 1/3. So we know that this line should be decreasing. We start at negative 2, 1, negative 2, 1. Now, negative 1 over 3 can either be written as negative 1 over positive 3, or it could be written as 1 over negative 3. Because when you divide a positive by a negative, or a negative by a positive, you get a negative. So let's use both ideas. From negative 1 over 3, that means you go down 1 unit and over to the right 3 units. That's where we'll land right there. And I can do that multiple times. Down 1 to the right 3. Or this says I could go up 1 to the left 3. Those points should all be points on the same straight line. So let's see if that's what happens. I go from 1 point, and there you have it. It goes through all those points, although my line is a little bit off, but you get the idea there. So other points on the line would be -5, 2. Another point would be 1, 0. Another point could be 4, -1. Let's try this point here. Let's try this point here. -1, 2, -1, 2, and this slope is -2/3, which again we can write as -2/3 or 2 over -3. -2/3 means go down 2 units and over to the right 3 units. Down 2 to the right 3. Down 2 to the right 3. Or we could go up 2 to the left 3. 1, 2, 3. So we have all of those points that form a straight line, and I can draw the line through those points. So then other points on this line, are -4, 4, 2, 0, 5, -2. Any of those could satisfy. Let's go on to this point here. At this point, we have -1, -4. So -1, -4. And this slope is 4 over 5, which we could write as -5 over 4, but there's no place to go downward. So we'll just use that positive 4 over 5. So I would go up 4 units and to the right 5 units. 1, 2, 3, 4 units to the right 5 units. 1, 2, 3, 4, 5. That's all I can use. That's all the space I have on this graph. And again, my graph is not exactly drawn to scale, but you get the general idea here. So another point on the graph that we can tell is the point 4, 0. So that is that easy there. Now, let's talk a little bit about finding the equation of the line. There are a number of approaches here. So the first case is if they tell you the slope and the y-intercept, and the y-intercept is indicated very easily. If the x-coordinate of the point is 0, that point is on the y-axis, and that's a y-intercept. If you know the slope and the y-intercept, just put the equation in slope-intercept form. So find the equation of a line whose slope is -5/4 and passes through the point 0, -3. That's a y-intercept because the x-coordinate is 0. So the equation is y equals to mx plus b, y equals to -5/4 x plus -3. And there you have it. If you only have the slope and a random point on the graph, on the line, what you do is you put the equation in point slope form. Y minus y1 equal to m times x minus x1. You substitute your y coordinate for y1, your slope for m, and your x coordinate for x1. And then you just solve for y, and that will give you the answer in slope-intercept form. Please make sure you pay attention to your pluses and minuses. If you're minusing a negative, that means adding a positive. All right? And of course, remember when you're adding fractions, you need to add the common denominator. And in this case, we're just adding whole numbers here. If you're given 2 points, all you have to do is find the slope by using the slope formula, y2 minus y1 over x2 minus x1 equal to m. Once you find the slope, just choose any of the points. Either point will work. Substitute into the point slope form, solve for y. Once you solve for y, you get the equation in slope-intercept form. And then please remember that if you have a horizontal line, the equation is just y equal to the y coordinate. And if you have a vertical line, the equation is just x equal to the x coordinate. That's it. Because in a horizontal line, the y coordinate does not change. In a vertical line, the x coordinate does not change. So find the slope, intercept, and standard forms of the equation of this line with the indicated slope. So let's do a few of these here. And again, I would recommend that you try these questions and then check your answer with in comparison to mine. Since we have the slope and the y-intercept, we'll start out with point slope form. Y minus y1 equal to m times x minus x1. And then you substitute y minus negative 3 is equal to m, which is 2 times x minus 4, which is y1, x1. You distribute the parentheses and simplify. We get y plus 3 is equal to 2x minus 8. Now, to get this into standard form, I would move the y to the right side and the 8 to the left side. So standard form would simply be 2x minus y is equal to 11. But for slope-intercept form, I solve for y, which would be y is equal to 2x, and then I subtract 3 from both sides, minus 11. So those are my two forms. Very simple. Again, in this example, same type of situation. Y minus y1 is equal to m times x minus x1. I won't write a formula each time, but I want you to get into the practice of writing the formula and saying it out loud for yourself so it sticks in your mind. So we have y minus 5 is equal to m, which is 3 times x minus negative 1, which I'll write as x plus 1. You distribute the 3, we get y minus 5 is equal to 3x plus 3. Now, for standard form, we put 3x minus y is equal to, we'll move that 3 to that side, negative 8. Or for slope-intercept form, you just solve for y. So we'll get y is equal to 3x plus 8 because you're adding the 5 to both sides. There you have it. In this example, again, simple. Y minus y1, y plus 3, is equal to m, negative 2, times x minus x1, x plus 4. Distribute the parentheses, y plus 3 is equal to negative 2x minus 8. And then for standard form, I'm now going to move the negative 2x to the left side and the 3 to the right side. I get positive 2x plus y is equal to negative 11. If you notice, we prefer to have a positive x for in standard form. We prefer to have the x being a positive number, and also as a whole number, or as our integers, sorry. The x and y coordinates, coefficients will want to be integers. So we end up with the slope-intercept form will just be solving for y. Y is equal to negative 2x. Now we subtract 3 from both sides, minus 11. In this case, if you notice, since the x coordinates is a 0, we're talking about a y-intercept here. We have the y-intercept right off the bat. So I just start out with slope-intercept form y equal to mx plus b. So y is equal to slope negative 4 times x plus b, which is 3. Because the coefficient, this x coordinate is 0. Didn't have to do much work for that one. So it looks too much like a 6. So the standard form, oh, this is slope-intercept form. For standard form, all I have to do is just put the 4x, the negative 4x onto the other side. And we have 4x plus y is equal to 3. In this case, this is not a y-intercept, that's an x-intercept. And we just have to go through the normal procedure. y is equal, y minus y1, so y minus 0 is equal to m times x minus x1, x minus 4. I'll distribute the parentheses, and y minus 0 is just y. So we end up with y is equal to 3/4 x minus 3. That is slope-intercept form. To get standard form, we multiply both sides by 4, so you get 4y equal to 3x minus 12. And then we put the y's and the x's together. So we'll just put the 4y to the left, to the right side, and the 12 to the left side, and reverse them. We get 3x minus 4y equals to 12. And that is standard form. In this example, point slope form, y minus y1 is equal to m times x minus x1, which is x plus 3 in this case. You distribute the parentheses, you get y minus 1 is equal to negative 2/7 x minus 6/7. And then I'm going to add 1 to both sides to get slope-intercept form, but adding 1 is the same as adding 7 over 7. So that gives me y is equal to negative 2/7 x plus 1/7. And that form is slope-intercept form. This is slope-intercept form. But now if I want standard form, I multiply all by the common denominator, which is 7. So I'll end up with 7y, sorry, equal to negative 2x plus 1, which gives me 2x plus 7y is equal to 1. And that is standard form. And it's a little tight, but I hope you can see how that works. Now we have this other example here. Y minus y1 is equal to negative 3/8. No, not negative 3/8, positive 3/8. X minus x1. And when we distribute the parentheses, we get y minus 4 is equal to 3/8 x plus 3/4. Multiply 2 by 3/8, you get 2 times 2 cancel with the a, leaving 4 in the denominator. If I add 4 to both sides, that's the same thing as adding 16 over 4 to the right side. And so we end up with y equals to 3/8 x plus 19 over 4. That's slope-intercept form. For point slope form, that point slope form for standard form, multiply by the common denominator, which is 8. So 8y equals to 3x plus 38. And then the standard form of that would be 3x minus 8y is equal to negative 38. When you get the x and y together with the x being positive, and get the number by itself on one side, and that is standard form. With this line here, the slope is 0. So we know it's a horizontal line, and if we do y minus y1, it's basically y minus 2 is equal to 0 times x minus 1. Well, 0 times anything is 0. So we get y minus 2 equal to 0. which means y is equal to 2. And this is both standard and slope-intercept forms. All right, let's move on to the next. Find the slope-intercept form of the equation of the line that passes through the 2 points. Very simple. If we have 2 points, find the slope first. So the slope is y2 minus y1 over x2 minus x1. So we just do 0 minus 4 over 3 minus 0. And that gives us negative 4 over 3. Now, this point here is the y-intercept because x-coordinate is 0. So b is equal to 4. And since they ask for slope-intercept form, I just do y equals to mx plus b, because again, this guy is because of the y-intercept in that point. We're just it just so happens that that point they gave us was the y-intercept. So you get y equal to negative 4/3 x plus 4, and that's the answer. In this case, they do not give us the y-intercept, so we have to do a little extra work. First, we find the slope. M is equal to y2 minus y1, 10 minus 12, over x2 minus x1, 4 minus 6. And that gives me negative 2 over negative 2, which is 1. So using point slope form, and let's say we use this point, doesn't matter which point we use. Well, again, I'm saying use this, but any point would be useful. So we do y minus y1 equal to m times x minus x1. That's point slope form. Y minus 10 is equal to 1 times x minus 4. Solving for y, we get y minus 10 is equal to x minus 4. So that means y is equal to x plus 6 when you add 10 to both sides. And that is your answer. Very simple. This one, find the slope. M is equal to y2 minus y1 over x2 minus x1. That gives me 0 over 4, which is 0. That is a horizontal line. If we have a horizontal line, the equation is just y equal to y coordinate. And since the y coordinates are the same, we're good there. Notice here that these 2 points have the same x coordinate, which means we have a vertical line. So when we find the slope should work out to be undefined. And that's what happens. We get a number divided by 0. That means no slope, undefined. So we're talking about a vertical line. And if it's a vertical line, the equation is x is equal to the x coordinate. And there we have that. Let's take a quick look at these examples down here. Find the slope-intercept form of the equation of a line satisfying the given conditions. The line passes through the point 2, negative 3, and the slope is 0. If the slope is 0, we're talking about a horizontal line. Horizontal line. And if the line is a horizontal line, then the equation is just y equals to the y coordinate. The y coordinate does not change for a horizontal line. If the slope is undefined, like in this example, then we're talking about a vertical line. And then that means that we're talking about x equals to the x coordinate of the line, which would be, in this case, x equals to 2. There we go. It contains the point 5/2, 0, and has an undefined slope. Again, undefined slope. We're talking about a vertical line. which means what? The equation has no y in it. It's just x equal to a number. What number is that? 5/2. So x equal to 5/2. And if the slope is 0, that we're talking about a horizontal line. And the equation then is y equal to the y-coordinate. By the way, side note here, if the equation is y equal to 0, we're talking about the y of the x-axis. This is actually the equation of the x-axis. The equation of the x-axis is y equals 0 because on the x-axis, the y-coordinates are always 0. All right, let's quickly get a few of these done here. Write the equation in slope-intercept form and then graph the line. So let's write it in slope-intercept form. We simply solve for y. Subtract 3x from both sides. And then divide by 2. So y is equal to -3/2x plus 3. Then we plot a point. The point we plot first is, so the slope is -3/2 or 3/2, and the y-intercept is the point 0, 3. You plot this point first. So we're going to plot 0, -3, sorry, 0, +3. And then using the slope, I will go down 3 units to the right 2 units. Down 3 units to the right 2 units. And once I have those guys, I can now graph my line. Hopefully I can graph it properly here. Almost, but you get the idea. There we go. In this case, again, we're always solving for y because we wanted to get y by itself. This is the most useful form, slope-intercept form. I'm going to add 3y to both sides and add 5x to both sides. So basically, I'm moving these guys to the other sides. So add 5x and add 5x and so add 3y and add 3y. So my equation becomes 3y is equal to 5x minus 6. And then I just divide both sides by 3. So we get y is equal to 5/3 x minus 2. So my slope is 5/3 positive. So the line should be increasing. And my y-intercept is 0, -2. So I start with 0, -2. And then I go up 5 units. 1, 2, 3, 4, 5. And to the right 3 units. 1, 2, 3. That's all I can do. So I'm going to use those 2 points to get my line. Close enough. Then with this one here, I just subtract 2x from both sides. And then divide both sides by -5. Now, if you notice, there's nothing added here, which means the y-intercept is what? The y-intercept is 0. So that means this line passes through the origin. So my first point is 0, 0. Then the slope says go up 2 units and over to the right 5 units. I could always go down 2 and go to the left 5, but I don't have enough space on this graph. So we do the best we can with what we have. And my line is not exactly where it's supposed to be, but it is pretty close. So that should be acceptable there. Let's go on to the next example. In this case, I want to get y by itself. I'm just gonna, I can add y to both sides. I can subtract 3x from both sides. So the equation becomes y is equal to 3x, negative 3x, plus 5. So my slope is negative 3 over 1, and my y-intercept has coordinates 0, 5. So I plot 0, 5 on the graph, and then I go down 3 units, 1, 2, 3, 1, 2, 3, to the right 1. And I can do it multiple times if there's space. 1, 2, 3, to the right 1. And then graph the line. Again, I may need to make a little bit of an adjustment. Make sure you're using your ruler properly with this. And there we have that. All right, let's go to the last part of this concept, which is parallel and perpendicular lines. Parallel and perpendicular lines. Now, when two lines are parallel, they are two lines in the same plane that do not touch. And when two lines are perpendicular, they're two lines that cross at right angles. If two lines cross, they are automatically in the same plane. So, since the slope of a line is how slanted it is, it makes sense that if two lines are parallel, they're slanted the same, so their slopes would be equal. So when two lines are parallel, their slopes are equal. If one slope is 1/3, the other slope is 1/3. Now, if two lines are perpendicular, if one is increasing, then the other one is decreasing, unless one line is vertical and the other is horizontal, which is its own case. But let's say neither line is vertical. Then if one line is increasing, the other line is decreasing. And as one line increases faster, the other one is decreasing slower, and vice versa, which gives us two insights, which we will not prove, but we're going to state them. If two lines are perpendicular, the slope of one is different from the slope of the other one by two conditions. They are negatives of each other, and they're reciprocals of each other. So the slope of one is the negative reciprocal of the slope of the other. If one slope is 1/3, the other one is negative 3 over 1. You flip the slope and change the sign. And that's it. So a couple of things I need to remind you. If two lines are parallel, then their slopes are equal. If two lines are not vertical and they're perpendicular, if neither line is vertical, then when you multiply the slopes, you will get -1 because they're negative reciprocals. When you multiply a number by its negative, you get the negative. You get a negative. And if you multiply a number by its reciprocal, you get 1. So if you have one slope is -3/7, and then the slope of the perpendicular line would be positive 7 over 3. If you multiply -3/7 by 7 over 3, you get -1. All right. So next up, if two lines are horizontal in the same plane, then they are parallel. If two lines are vertical in the same plane, then they are parallel. If one line is horizontal and the other one is vertical, then they are perpendicular by definition. So once we remember those things, now we can do a lot of things with the equations of lines. So let's do a couple of examples here. Let's start off with this example. Let's check something here quickly. All right, so 2 points are given from each lines L1 and L2. Without graphing the points, determine if the lines are parallel, perpendicular, or neither. If the lines are perpendicular, the slopes are negative reciprocals, or they multiply to be -1. If the lines are parallel, the slopes are the same. If neither of those conditions occur, then the lines are neither parallel nor perpendicular. So let's take a quick look at this. For the slope of line 1, I'm going to write out M1. Remember now, slope is y2 minus y1 divided by x2 minus x1. So this is, let's do 2 minus negative 5 over negative 1 minus negative 3. That gives me 2 plus 5 is 3, is 7, sorry. And negative 1 plus negative plus 3 is 2. That's the slope of line 1. Now let's take a look at the slope of line 2, which I'll call M2. We have 2 minus 4 over 7 minus 0. 2 minus 4 is negative 2 over 7. If you notice, the slopes are not equal. M1 is not equal to M2, so the lines are not parallel. And there's a little shorthand symbol we use for parallel, which is basically, we just write two lines that are parallel like that. So when we multiply the slopes, M1 times M2, you realize that that works out to be 7 over 2 times negative 2 over 7. That's negative 14 over over 14. That's negative 1. So the lines are parallel. So M1 is perpendicular to M2. This symbol means perpendicular. It's an upside down capital P, capital T, and it indicates two lines are perpendicular. So perpendicular. And there we have it. These two lines are perpendicular because the slope of one is the negative reciprocal of the slope of the other one. When you multiply the slopes, you get negative 1. Let's try these two guys. The slope of line 1 is y2 minus y1 over x2 minus x1. That gives us 6 over 0. That's undefined. Which means this is a vertical line. Let's do the other one. M2. We're talking about 2 minus 2 over 0 minus 4. That gives me 0 over negative 4, which is 0. That is a horizontal line because the slope is 0. Since the line is horizontal and the other line is vertical, the lines are perpendicular. Oh, sorry, I should have written here. L1 is perpendicular to L2. Now they're slopes. The slopes are numbers. The lines are perpendicular. So L1 is perpendicular to L2 again. Again, because the vertical lines are always perpendicular to horizontal lines. Remember, I'm just rewriting that perpendicular. The shorthand symbol is an upside down capital T. Let's take a quick look at this one here. Slope of M1 is 0 minus 1 over 0 minus 7, which is negative 1 over negative 7, which is 1/7. And the slope of M2 is negative 6 minus negative 8 over 4 minus negative 10. That gives me negative 6 plus 8 is 2. And 4 minus negative 10 is 14. That gives me 1/7. Since M1 is equal to M2, then line L1 is parallel to line L2. This symbol represents parallel, which means the lines are parallel. It looks like two parallel lines. They are in the same plane and they do not touch. They have exactly the same slope. Let's go on to the last example here on this page. We have the slope of M1 is 3 minus negative 2 over 2 minus negative 3. And that gives us 5 over 5, which is 1. And then the other slope, M2, is 5 minus 1 over 0 minus negative 4. That gives us 4 over 4. And again, the slopes are equal. So M1 is equal to M2. So line L1 is parallel to line L2. Now, just as a side note here, if we had gotten an example or result where they're not parallel and the slopes don't multiply to be -1, then we would have chosen neither as our answer. Now, let's take a look at another example here. What if we want to find the equation of a line that is parallel or perpendicular to another line that we know? So here's our line and a point that's not on the line. The line has equation y equal -2x. So it passes through the origin and its slope is -2. And then this other point is as 2, 4. What would be the equation of the line that is parallel to this given line, y equal to -2x, that passes through this point, 2, 4? So what we would do is we would say, okay, since the lines are parallel, then their slopes are equal. So if this line has a slope of -2, then that means the slope of the line we want is also -2. So we want the equation of a line whose slope is -2 and passes through the point 2, 4. That's easy. Just do point slope form. Y minus y1 equal to m times x minus x1. I substitute. Plug in -2 for the slope. Plug in 2 for x1. Plug in 4 for y1. And then solve for y. Once I solve for y, distribute the parentheses and combine like terms. We get y equal to -2x plus 8. So then I plot the point 8, and then I can use the slope to get the same value, down 4 over 2. And there we have our answer. Very easy. Once you know the slope of one line, then this is the slope of the same slope will work for parallel lines. What if we were doing perpendicular instead of parallel? So same line, same point not on the line, but now we want the equation of the line that's perpendicular to this line, but is passing through the same point 2, 4. Since the slopes are negative, since the lines are perpendicular, the slopes would then be negative reciprocal. So I'll take the slope -2, and I would flip the number and change the sign. -2 is the same as -2 over 1. So when I flip that and change the sign, I get positive half. So the slope of my line is now half the slope of the line that I want. So I put my point slope form. I substitute y minus y1 equal to m times x minus x1. x1 is 2, y1 is 4. Distribute. Y minus 4 is equal to half x plus minus 1. And then add 4, we get y equal to half x plus 3. So your y-intercept is now 3, and your slope is now 1/2. And there you have it. And now let's do a few examples. Find the line that is parallel to the x-axis and passes through the point 4, 5. If it is parallel to the x-axis, that means it goes horizontally. The x-axis is a horizontal line, so any line parallel to it is also a horizontal line. So the equation is just y equals to the y-coordinate. So the equation is y equals to the y-coordinate, and the y-coordinate is 5, so it's just y equal to 5. Now, what if that line is perpendicular to the x-axis? A line that's perpendicular to the x-axis has to be a vertical line because the x-axis goes horizontally. So a line perpendicular to it would have to be going vertically. And since the line is vertical, then the equation is x equal to the x-coordinates. So x equal to 4. Now, this line we want now is parallel to this given line here, which itself is a vertical line. Since x equal to 4 is vertical, then the desired line is also vertical because vertical lines are parallel. So we're talking about x equal to a number, and that number in particular is 5 because the x coordinate is what we're going to use. Now, if its line is instead parallel to a line y equal to -2, y equal to -2 is a horizontal line. So again, since y equal to -2 is horizontal, then the line we want, the desired line, is also horizontal because it's parallel to a horizontal line. So the equation is y equal to the y coordinate, which is 4. So y equals to 4. And I would encourage you to generalize. What about if it's perpendicular to a vertical line, and so on? In this case, we want to find the equation of the line that is parallel to the line 3x minus 4y equal to 8. But it passes through the point 4, -2. In order to do that, we need to know what the slope is for this. So first, find the slope of the given line. And the given line is 3x minus 4y equal to 8. To find the slope, I just solve for y. So I subtract 3x from both sides and then divide by -4. So we get y is equal to -3 over -4, which is positive 3/4 x minus 2. The slope here is 3/4. Now, since the lines are parallel, then the slope of the desired line is the same because the lines are parallel. So using the point y for -2 and the point slope form, we just use y minus y1 equal to m times x minus x1, and then we just solve for y. So we do y minus -2 equals to slope 3/4 x minus 4, and then we solve for y. Distribute the parentheses, we get y minus y plus 2 is equals to 3/4 x plus 3. And then we subtract 2 from both sides, we get y equal to 3/4 x plus 1. And as you can see, we have, if you plug in 4 for x, you will get -2. Oh, sorry. I made an error here. I should have had a -3. So this should have been -5. So that's why we need to check. Plug in -4 for x, you get y equals to 3 minus 5, which is -2. And that is the equation of the line that is parallel to that given line through that given point. Now let's try this one here. This time the lines are perpendicular and they pass through a different point, but the line we want to pass through a different point. We still need to know the slope of the given line because the slopes are still related, albeit in a different way. So find the slope of 3x plus 2y plus 3y plus 2x, sorry, 3y plus 2x equals to 21. I solve for y, subtract 2x from both sides, and then I divide by 3, so y is equal to -2/3. x plus 7. I don't care about the y-intercept for this line. I only care about the slope. And the slope is negative 2/3. So the slope of the line we want, if the lines are perpendicular, the slopes are not the same. So slope of the line we want is the negative reciprocal. Change the sign, flip the number, is 3/2. So I'm using my point slope form, y minus y1 is equal to m times x minus x1. My slope now is 3/2, which is the negative reciprocal of this slope. So y minus 4 is equal to 3/2 times x minus 2. We distribute the parentheses. We get y minus 4 is equal to 3/2 x minus 3. I add 4 to both sides. I get y equals to 3/2 x plus 1. And that's the equation of the line we want. So in both cases, we have to find the slope of the line that is given, but depending on whether the line that we want is parallel or perpendicular to the given line. If I plug in 2 for x, I should get 4 for y. 3/2 times 2 is 3, and 3 plus 1 is 4. So that works. And that brings us to the end of our lesson on equations of lines. And of course, with a linear function, is simply a line that is written in slope-intercept form. We'll get that into, you can develop that concept more with together with the concept of functions. And as I wrap up here, I strongly recommend that you look up the videos on Khan Academy. They have excellent videos that explain the concept as well as good practice exercises for you to work on. Khan Academy, Khan Academy, Academy, khanacademy.org. All the best until the next video.